Have you ever stopped to wonder how you can hear your favorite song, the voice of a loved one, or even the annoying sound of a car horn? Well, let's take a moment to appreciate the omnipresent phenomenon of sound that shapes our daily lives. From the moment we wake up, greeted by the chirping of birds or the hum of city life, to the last few moments before we drift off to sleep, accompanied by the soft whispers of the night, sound is our constant companion. It's in the laughter that brightens our day, the music that soothes our souls, and even in the silence that offers us respite. And it's not just about what we hear. Every vibration, every resonance, every echo is a testament to the incredible journey of sound. So what's the secret behind this auditory marvel? How do these sounds reach us? The answer lies in the fascinating science of sound waves. Understanding sound begins with understanding its building block, the sound wave. So what is a sound wave? It's a disturbance that travels through a medium, such as air, water, or even a solid object, carrying energy from one location to another. Now, you might be wondering, how does this disturbance happen? It all begins when an object vibrates. This vibration causes the particles of the medium around it to also vibrate, setting off a chain reaction that we perceive as sound. Here's a fun fact. Sound waves are also known as longitudinal waves. This means they move in a direction parallel to the direction of the energy being transported. Picture a slinky. If you push and pull one end, the coils of the slinky move back and forth along the same path that the energy takes. That's pretty much what happens with sound waves. Now let's dive a bit deeper into how sound waves work. The two main components of a sound wave are compression and rarefaction. Compression occurs when the particles of the medium are close together, while rarefaction happens when these particles are spread apart. Imagine again your slinky. When you push the end, you're creating a compression as the coils bunch up. When you pull it back, you're creating a rarefaction as the coils spread out. In the world of sound, these compressions and rarefactions are what create the high and low pressure areas that our ears interpret as sound. But remember, sound waves need a medium to travel. They can't move through a vacuum like light waves can. That's why, in the vacuum of space, no one can hear you scream, or play a symphony for that matter. It's also why sound travels faster in solids and liquids than in gases, because the particles are closer together and can more easily pass the vibrations along. Sound waves, with their compressions and rarefactions, carry the sounds we hear every day from their source to our ears. So next time you listen to your favorite song or hear a car honk, remember the incredible science that's making it all possible. But how do these invisible sound waves convert into the audible sounds we hear? Well, let's dive into this fascinating process. Imagine sound waves as invisible ripples in the air around us. When these ripples reach our ears, they cause our eardrums to vibrate, much like the surface of a still pond disturbed by a pebble. These vibrations are then transformed into electrical signals, which travel along the auditory nerve to our brain. The brain is a master interpreter, turning these signals into what we perceive as sound. Now, what about the diversity of sounds we hear? That's all down to frequency. High-frequency sound waves produce high-pitched sounds like the tweet of a bird, whereas low-frequency waves give us deep, bassy sounds like the roll of thunder. Each sound we hear is a unique combination of different frequencies. So, the melodies of a symphony, the words of a speech, or the cacophony of a city street all come down to how our brains interpret different sound wave frequencies. So, we've taken a deep dive into the fascinating world of sound waves. We've explored how sound, an element so integral to our lives, is everywhere around us. It's in the gentle rustle of leaves, the hum of city traffic, and the soft strumming of a guitar. We've learned about the nature of sound waves, their formation and propagation. We've discovered how these invisible vibrations travel through different mediums, like air, water, and solid objects, to reach our ears. And we've understood how our brains interpret these waves to create what we perceive as sound. It's a complex process, but it's happening every second of every day, allowing us to communicate, enjoy music, and navigate our world. Next time you listen to your favorite song or hear a friend's voice, remember the incredible journey those sounds took to reach your ears. It's all thanks to the science of sound waves.